So
Okay, cool. Let's see.
I'm good with being done by 7. So I understood this week's preparation pretty well. I thought it was easy-ish. I just had one, like the third one kind of tripped me up. I didn't quite understand how they got the answer they did, but that's okay.
Like sine 75 plus sine 15?
No, the sine of 13 pi over 24.
Oh, I guess I didn't finish that one.
See, like I got to the very, very end, and then I was like, hey, I got the answer right. Like I was so proud of myself. And then I looked and I was like, how in the world did that happen? Like, I'm pretty sure I did all the other steps right. It's just the last step. I'm not quite sure. Because it ends up being 1 over 2 root 2 plus square root of 3 over 4. And I got square root of 2 plus square root of 3 over 4. So that's my only issue.
13. Sorry, 1 second. I'm trying to finish it. Because apparently I didn't finish it.
well, good for you guys for preparing.
You've been a little busy this week?
Yeah. But we present on Thursday, and then after that.
Wait, what? We have to do a presentation?
No.
Oh. I was like,
I think you terrified Natalie.
I was like, shoot, I don't have time.
So, like the thing is so my research group, like we're presenting our stuff on Thursday, and we have to have our poster done by today to get it to the printer to be ready to present on Thursday. So everything has been crazy through today, and we're meeting tonight to finish off our poster, and that's why like everything's been crazy. But since we're finishing that today, I will be prepared for our last meeting on Thursday.
Yay!
Awesome.
But just
so you guys do want to do it on Thursday at the same time?
Oh yeah. So here's the other thing.
Oh no.
I'm willing.
Oh, Alexandra.
Hi.
Hey, Alex.
Hi.
How are you doing?
Good, how are you?
Good. So, for this Thursday, I'm fine taking the hit of being absent if you all want to work, like do the same time. But the problem is that someone else would have to set it up, and so I don't know if you remember how to do that. And I can like
show when's your meeting?
My conference is from 5 to 6 on Thursday, but we have to meet beforehand and set it up and everything. So I don't know. I don't think I can meet beforehand, and I don't want to like put you guys out of your way. And so I would be willing to take the absence since I can't be there at the time. But if you still want me to set it up like I always do, I can't do that time.
We can just, can you do it earlier on Thursday? Like we could do it in the morning. We could do it, because I just can't do Wednesday. Wednesday, I have class from like 7:45 until 6 at night.
Yeah, I'm done with classes at 2 on Thursdays.
I am free until 9:45 on Thursday.
Agreed.
In the morning?
Yeah, but I know that's, I mean, I don't.
That is early.
I know. Because I have an 8 o'clock class, but our last day was today. So I have that hour and a half free now.
I have 7:45 to 8:45 on Thursday. Maybe if we prepare really, really good and we can maybe get through.
Are you guys busy Thursday night, like at 7?
7, I'm free.
On Thursday.
I'm free. So.
Would you guys want to do that?
Yeah.
I feel so bad, but it's like I can show someone else how to set it up, and you can do it at the regular time, or we
No,
can.
I think it's finals week, and so I think it would be good for everybody to do it later anyway. So, no worries, Lisa.
So, I'll put that in my calendar then for Thursday at 7.
Awesome.
Sounds great.
Perfect. Thanks, guys.
So, oh my gosh, I just got a text message. So my meeting is with Bishop, and it changed from 7 to 6:30. He just texted me. Is there any way we could finish before then, or no?
Let's do what we can. Just we'll try to breeze through it.
Okay.
Do we have a quiz today or anything? I don't think we do.
No, since it's Tuesday, we should be good.
Okay.
So let's just breeze through these, and we can spend more time on anything anybody has a hard time with. I locked my husband out, sorry.
Okay. Did you finish that third one real quick?
Oh, sorry. I'm still working on it. But so I got 3 pi. So I got sine 3 pi over 4. And then I'm just getting the other one.
Okay.
Okay. So our final exam is all online, right? Like we don't have to be in the testing center.
Well, at least that's as far as I understand, yeah.
Okay, because I will be gone out of the state.
When is graduation?
It's on the 18th. So in 1 week. And then I'm done.
Yay!
I can't even celebrate yet. I'm so stressed out.
Yeah, because you're trying to move and graduate.
My house is a total disaster, and I look like I live in a drug house. Literally, I have a mattress on the floor and crap everywhere. But it's okay.
It'll all be worth it.
So,
Sorry, I'm almost done.
preparation activities. Are you ready to do the prep activities or no?
Oh, me?
Yeah.
I was just doing the third one. So I've gotten to 9 pi over 12 plus 4 pi over 12 equals 11 pi over 12. But I don't know how they got 1.
Wait, the third one I was asking you?
Huh?
Well, Natalie?
Yeah. Wait, hold on.
I did it where it's sine 3 pi over 4 plus sine pi over 3. I got that part.
Same here.
But then over 3 pi over 4, it should be square root of 2 over 2 plus square root of 3 over 2. I don't know how they got the 1 over the 2 root 2. That's just where
I don't know how they got that either. I am so confused.
okay, then. We can move on then.
Okay. I think if we get, oh wait, hold on. So sine 3 pi over 4 is pi 2 over 2, if you look on the unit circle, right? And then cosine pi over 3 is 1/2.
Mm-hmm.
Do you see that?
Yeah.
So then maybe it's oh.
Wait. Wouldn't it be sine and sine?
Yeah, you're right. Sorry. Oops. So then it's pi 3 over 4.
Plus square root of 3
So
over
then you just go over, so it's square root of 2 plus square root of 3 over, do you just add it across or no?
Apparently not, because it somehow puts the 1 over 2 root 2. By the half.
Oh, oops. So then it would be anyways, I don't know. We'll move on.
Okay.
Yeah.
Let's see. I'm not exactly sure where we're supposed to like. So you discussed 1 through 3. Did you discuss number 5?
No. Well, we can go over that one real quick.
Okay.
So for that one, a lot of it was just the inverse sine, inverse tangent, or number like the third and fourth one were probably the hardest, and I felt like those are easy. Did you get those, Natalie?
4 and 5.
Or 3 and 4 on number 5.
Sorry, say again.
On number 5, the 3 and 4th one.
Yeah, I did. Did you? I think she's frozen.
Oh yeah, she is. I was like, she's being really quiet for being asked a question.
Wait, so this is our last week. We don't have anything next week?
Yeah, we just have this one Thursday, and Thursday we're spending preparing for the exam, and then that's it,
Okay, cool.
which is crazy.
Whoa, we have a lot.
We have a what?
A lot to do. Okay, well, so what number are we on for the team discussion?
5. Let me get to that, back to that page. I think I get them pretty decently. And then there was the third point that says, using those solutions from number 5, write each solution as an all solution set. So that
I don't know.
I think that's the type of thing that you say, like, this number and then plus, whatever other ones will make that solution. So if you go around the circle again, that would equal it if you go around again. So like plus or minus.
How would you write a solution set?
I think I'm gonna look at the key just to make sure I'm not totally off though. Oh, they're only for the extension problems. So, well, that's my guess, is that it's like, write it so that it's not just that number, but no matter how many times you go around the circle. So I would say it's like plus or minus 2 pi x. So then you put in x, and that's how many, with x being a whole number.
Mm-hmm.
I don't know the exact way to say it, but that's kind of the idea of it.
Okay, sounds good.
And then reduction theorem. As a team, review the materials in iLearn about the reduction theorem. Ensure that each team member is able to find each part of the reduction theorem. Rewrite y equals negative sine of x plus root 3 cosine of x using the reduction theorem, and then graph the function. Welcome back.
Hi, sorry, this one told me nobody's business. So where are we at?
We are on the reduction theorem,
Okay.
just the first point. So rewrite it using the reduction theorem and then graph the function.
What's the reduction theorem? Oh,
Not right now.
is that let's see. Is it?
The reduction theorem. However,
Is
something
it
else it
this?
can be called.
Integration? Maybe.
Is this it?
That looks like it's right.
Yeah.
Don't ever use Wikipedia to help you with math because there's just numbers and letters everywhere. There's like too much information. I'm gonna look through the resources. Reduction PowerPoint. He has posted. This is the reduction formula. Yeah, so it's the one you showed. A sine of x plus b cosine of x equals square root of a squared plus b squared sine of x plus a for any
Wait,
real
what?
number x. 1 sec, I'll put you on the screen. There we go. Okay. Here, can you see this?
Hold on. So, okay. So then how would we put it in? Hold on, let me write that down. Okay. So then to write it in, would you just do, let's see. So rewrite y equals negative sine x plus square root of 3 cosine x. So then we would do negative sine x plus square root of 3 cosine x equals negative 1 squared plus square root of 3 squared sine x plus negative 1. Like this.
I'm so lost right now. Maybe that.
So I just kind of took the equation. So
Oh yeah, a squared plus b squared times sine of x plus.
-1 because I took the -1 from.
Yeah.
Okay. That's how you find it, right?
Let me double check. Yes. Well, maybe. You don't have alpha. You have to find alpha. Because it's x plus a, or sorry, x plus alpha, not x plus a.
Oh.
So what it said is to take alpha and then draw it like it was on the unit circle or whatever. And you've got a is the like the x axis, b is the y axis point, like.
So.
And then that's your point AB. So it would be -1, 3, was it?
Square root of 3.
Yeah.
But
And then you have to take that and that, write a triangle, and then figure out what alpha is.
Okay, and alpha
And
would
then
just
you add
be.
alpha into the equation. So if
Alpha
you pull
would
up this
be-
PowerPoint, it's really helpful.
Okay. Cool. But we just had to rewrite it, right? So we don't have to solve it.
Using the reduction theorem. And then graph the function. Yeah.
So then, graph it.
I think that just means like put the little triangle on. Think. Maybe not. Okay. Do you guys get that?
Yeah, I get that.
Okay. Solve sine of 2x equals sine of x for all solutions. So I think this is going to be another one of those ones that you just find, like sine of 2x equals. Oh wait, now I'm confused.
So would it be, could we throw the sign in front, or the 2 in front of the sign? So do 2 sine x.
No.
I think so. Because like if you were to put a half in that x's, that totally changes the answer.
Yeah, you can't, it doesn't just move like that. I think it does move like that if it's like an exponent or something. Or maybe that's with logs. I don't remember, but it doesn't.
It's a flaw.
But there, you use the double angle. Whatever, but I just. I don't know. I'm going to move on to the next one and see if I can figure out this one. Cosine of 2x equals 1 over root 2 over root 2 over 2 for solutions 0 to 2 pi. So anywhere cosine. So that would be in the first and fourth quadrants, right? And that would be at 45 degrees and whatever 45 degrees is in the fourth quadrant.
Yeah. Okay. That makes sense.
Maybe, except there's a 2x, so I don't know. So maybe like 45 degrees divided by 2. Pi over 8, maybe?
Yeah. Yep.
Cool. Oh, there's an example. I think this is going to guide us through it. The following work guides you through solving tangent of 3x plus 1 equals square root of 2 secant 3x for all solutions. Based on the previous problems you have solved, what is the issue in solving this equation? What identity can be used that relates to tangent of x and secant of x together? So the first question, let's answer, what is the issue in solving this?
Well, they're not the same, so that makes it.
Yeah, and we don't have it in terms of like sine and cosine. And so our identity is the, like,
Pythagorean.
is it like 1 plus tangent equals 1 plus tangent squared equals secant squared, or
Yes.
that one? I might have it out of order.
No, you.
Okay. And then what do you need to do in order to use this identity? We,
Squaring both sides.
oh yeah, square both sides.
Wait, what would you do? Oh, square both sides.
Is this going to
So,
help us?
what, I couldn't hear you guys. What did you say? What identity would we use?
1 plus tangent squared equals secant squared.
Tangent squared plus 1 equals.
1 plus tangent squared x equals secant squared? Okay.
Yeah. Make sure that you're using the right one, because I might have said it wrong. I always get those ones mixed up, but that one.
I think you said it right. Oh, which one? Sorry, hold on.
Tangent squared
Did you
plus
show us
1
or no?
No, I didn't.
Oh, okay. I thought you showed us something.
Yeah.
Okay.
So we square it and then perform the operation, make sure that you multiply it correctly. Now that it is multiplied out, use the identity in order to get rid of the secant of 3x function and simplify. You should have the following. Tangent squared of 3x plus 2 tangent of 3x plus 1 equals 0. Okay, I see what they did there. So they squared both sides, and then they like carried out the squared one to make it into like an equation that says like tangent squared plus tangent plus 1. Get it?
1 second. Say that one more time.
So with their equation, tangent of 3x plus 1 equals square root of 2 secant of 3x.
Yeah.
They squared both sides, and so they took each one of those and multiplied it by itself and carried it out like the FOIL method.
Okay. Yeah.
So that gave them tangent squared of 3x plus 2 tangent of 3x plus 1 equals 0.
Okay, that makes sense.
This equation now looks like what familiar function? Looks like a quadratic function.
Yeah.
How can we solve it? It may be useful to use a u substitution of v equals tangent of 3x.
substitution in forever.
Huh?
But I haven't used U substitution in forever.
I don't know what it's talking about.
Oh, I think I remember. It's like, since one equation equals v, then you take that whole equation and you put it in for v equals y, or u. Does that make sense?
I vaguely remember that.
So if it's like v plus u equals 5, and then u equals 3, or 5 minus 3. That's a 5. Hold on. Kind of like this.
V plus u equals 5, u equals 5 minus 3. So you'd put
So since u equals,
plus 5 minus 3 equals 5.
yeah, so then u equals 2, then you have to do 5 minus 3 equals 2. So u is 2, and then you put 2 in for u, and then you solve for v, right?
Okay,
So that's substitution, I think.
right. Okay. So, okay, by solving, we should now have tangent of 3x minus 1 squared equals 0. I don't know where they got this minus sign from.
Where? What minus sign?
Well, because it used to be tangent of 3x plus 1 squared. Now it's tangent of 3x minus 1.
Oh, squared. Yeah. I don't know.
We can solve using the zero product theorem. Tangent of 3x equals 1. 3x equals tangent inverse of 1. So wherever tangent is 1 is at 45 degrees, so pi over 4. So 3x equals pi over 4. Both angles. So I think that that's in the first and the third quadrant. So pi over 4 and 5 pi over 4. Is that right?
Yes.
Cool. And then
Yeah.
we stop here to answer the question of whether both answers are correct by checking in the original what do you find? 3x equals pi over 4. Yeah. So now, I see. So we check our answer by putting in pi over 4 anywhere where it says 3x. So it would be tangent of pi over 4 plus 1 equals root 2 secant of pi over 4. And then we just see if they equal each other.
Okay.
As discussed in the resources on iLearn, if we are looking for all solutions, we must either add pi k. Oh, that's how you do it. You add the k, which means like any integer. So we either add pi k or 2 pi k before dividing. Which will we add? And I think it's pi k because we have it in opposite quadrants. So it's like every pi, right?
I think so. I don't know.
Oh, okay. We messed this up.
Oh, we did?
Because it says, which will we add? Remember that one of the solutions was false. So that's what you do is you put in, we have pi over 4 and 5 pi over 4. So we had to put in both of those into those original equations. And one of them would be true and one of them would be false. And the false one was the 5 pi over 4. They don't equal each other. So we know the only situation in which those two equal each other is when 3x equals pi over 4.
Oh.
That's the only one we carry into this next part of the problem. And so because it's only pi over 4, it's only in that one quadrant, you're only getting that answer again once around the circle, which is 2 pi. So you're adding 2 pi k.
Yeah.
I think I get it.
That's crazy how much that just like came back to me so fast.
So, okay. So you kind of have to see, like, put in the numbers and see which one works and which one doesn't.
Yeah, since we came out with like anywhere where tangent is 1, we had in the first and the third quadrant. So we had pi over 4 and 5 pi over 4. So then you need to take those back into our original equation.
Oh, that makes sense. That makes sense.
For each of those numbers and see in which case of 3x do both sides equal each other. And it's only when it's 5 pi over 4. I mean, sorry.
Okay.
Only
Pi
with
over
pi over 4. And then this little squiggly thing that they have down, like squiggly X, line X. I don't remember how to say that in English. But it looks like they just took pi over 4 and divided it. They divided it all by 3 because we had 3x equals pi over 4. So now they have x equals pi over 12 plus 2 pi k over 3, since they divided both by 3.
Makes sense. I get it.
Cool. And then you can check your solution and make sure it is correct in the original equation. I'm sure it is. Okay, so extension problem. Do you guys have any questions about that?
No, I think that makes sense. What would that be called? If we found that on a test, what would that be called?
That's
Like, what would they?
a reduction equation or reduction identity.
Reduction formula equation.
The main word is reduction.
Okay, cool. Good to know.
So an extension problem, find the solution from 0 to 2 pi for 6 sine squared of x minus 2 cosine of x equals 5.
So then you just put that in your reduction equation. So then it would be like 6 sine. Wait.
5 over.
Huh?
Don't you move over the 5 so then it equals 0?
Yeah, that's what I was thinking. That would be the first step, so that then you can factor it out.
Oh, okay.
And so then that would give you, you can move over 1/2 and say this equals this, right?
Okay. So then you'd subtract 5, right? Subtract
Yeah.
5. So
Yeah.
6 sine squared minus 2 cosine x minus 5.
Oh, wait. This is going to be hard to factor because,
It's sine and cosine.
yeah, I didn't realize that. Maybe we're not supposed to.
Could we change it to sine somehow? But what about the sum to product formulas? Or product to sum formulas? So sine u, cosine u, so it'd be 1/2 sine u plus v plus sine u minus v.
That sounds right.
So we use the product to sum formula, sine u, cosine v, in the reduction formula, right?
I don't know.
So I
I'm
think
looking
that's what we would have to do first. So we do you guys have that equation?
Oh, yeah, those ones.
See how it's like cosine, sine times cosine?
Is this a paper you have from high school?
Nope, this is from the math lab. Yeah.
Cool. Because that seems very handy to have.
It's super handy to have.
I should probably go there.
I have 2. I found 2 in my backpack.
Nice.
Yeah, they're free too. I'll
Awesome.
just give you one.
What? Oh, so we're supposed to change sine to, oh, okay. We say change sine squared to 1 minus cosine squared.
Oh, we could do that.
So it's like 6 parentheses, 1 minus cosine squared, minus 2 cosine of x equal, minus 5 equals 0.
Wait, what? Say that again?
6 parentheses, 1 minus cosine squared of x parentheses.
1 minus cosine?
Yeah.
Square.
That's like the sine squared plus cosine squared equals 1. So 1 minus cosine squared, we're replacing for sine squared.
Square root of x? Sorry. So like this?
No square root.
Oh.
We're
so
just
then
replacing
it'd be
sine squared of
sin-
x with 1 minus cosine squared of x. You're using the Pythagorean identity. That's the one that says sine squared of x plus cosine squared of x equals 1.
Uh-huh.
And that could be flipped around to say sine squared of x equals 1 minus cosine squared of x.
Oh.
So we've just replaced it so that we have it all in terms of cosine.
You keep saying sine squared of x, or sine square root of x, right?
Do I? Am I saying that?
And so I was like, wait, I'm confused. So it is cosine 1 minus cosine to the power of 2.
Maybe I say squared, like really emphasizing my R's or something, but
Maybe. I don't know.
there's
was like,
no
wait.
square roots anywhere.
Okay, cool. So 6, 1 minus cosine to the power of square, or to the power of 2, x.
Yes.
And then minus 2 cosine x.
Yeah.
Minus 5.
Oh gosh. Let me grab my notebook. Doesn't matter, I just need Jason.
Okay, cool. So then now from there we what is it? Factor it out.
You have to like multiply out the 6's first. Because you have 6 times 1 minus cosine squared of x. So it would be 6 minus 6 cosine squared of x.
So then it would be minus 1/3 cosine x, right?
No.
Because if we multiply it out 6, it'd be 6 times.
Here, let me show you what I'm talking about. Just 1 second. So we have
Sorry, I am so bad at this.
sine squared of x minus 2 cosine of x equals 5. That changes to 6, 1 minus cosine squared of x. I hear it in my own voice now. I say squared and it sounds like square root, but I'm saying squared, I promise. Okay. 1 second, and then I'll have it.
So 6. Oh, that makes sense. Hold on. Sorry, I'm still writing it.
Okay.
You have great handwriting, by the way.
Thanks.
And then 6, negative 6 cosine squared x minus 2 cosine x plus 1?
Yeah, because that's like we took a 6 and a negative 5 and added them together.
Okay, cool. So then so that's factoring it out, or that's distributing or taking out the 6, right? The common factor.
No. Yes. No.
That was just a thing. Because we had to change that sine squared into sine squared and then distribute.
Oh, distribute the 6.
So here, I don't think we factor this out. I think that
we just do the square box or the square method, right? So then it's
so I'm looking at the key right now, and we're supposed to replace cosine of x with v. So then it's 6v squared plus 2v minus 1.
Yeah.
And then we do
And then
something with v. Now I'm lost.
Isn't that the square root method? The like plus or minus b square root of b squared minus 4a
All over
ac.
2a. Yeah, that's what that. Although I don't really remember that at all. It's like negative
there's a song,
plus
right?
or minus the square root of 2
AB minus something.
Yeah.
I don't know the song. I didn't know there was a song, but yep.
What's this called?
I'm gonna
All over.
Pythagorean theorem.
Where's my blue book? There it is. Quadratic formula.
Oh, the quadratic.
Formula. I don't want a calculator, I just want a quadratic formula.
No. You guys want to hear the song?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yep.
There's sing us this song.
Okay, I'll play it. I found it on YouTube.
Okay.
Quadratic formula negative b plus or minus square root of b squared minus 4ac all over 2a.
Can you hear that? Could you hear
A little bit.
I heard like the tail end of it.
Okay, well anyways. Okay, let me write that down.
Okay. Yeah, me too. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And then you just plug in. So we replace cosine of x with v, and then plug it into the.
So how would that look written out?
So we have 6 or negative 6. I don't know why they got rid of their negative sign here. I don't know. Negative 6 cosine, or negative 6v
Wait, what?
squared. So I had 6 minus 6 cosine squared of x minus 2 cosines. Oh, they
distributed it out.
They like made it backwards so that it's all positive and it's minus 1 instead of plus 1. I see. So
yeah, they took out that negative. So then even
all
the
the
sign is now
So
positive.
6 is positive now?
Yeah, so they flipped all the signs. So now it's 6v squared plus 2v minus 1. And now I can say x equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 6 times negative 1. So plus 4 times 6 all over 2 times 6 equals negative 2 plus or minus the square root of, it's 4 times 6. 12, 24, 28. All over 12. Yeah. Well, so that's what x is this v that we've replaced in the formula. Oh. Ooh. So now we have cosine of x equals -2 plus or minus the square root of 28 all over 12. Okay.
So then that breaks it down into 2 plus square root of 12, and then x also equals -2 minus square root of 22.
Yes, so we have two answers.
And we just have to see which one's false. Right?
They
Both true.
both could work. We just have to go back through the equation and find out if they both do.
Yeah.
Okay.
So we find like a number, two numbers for this. So cosine of x equals, so square root of 28
Hold on.
is -2 Okay, so the first one is if we add 28 or add the square root of 28, it's 0.274. And the second one is sorry, I'm on my phone, so this is taking forever. -7.29. Nope. Oh, I forgot to divide by 12. Okay, I got it. Equals -0.608. Are you guys following? Do you know what I'm doing?
Yeah.
I've just worked out that -2 plus or minus the square root of 28 over 12. I worked out the plus side and the minus side of it to give me a decimal.
Yeah.
So my two decimals are 0.274 and -0.608. So now I find out, like, because that's what cosine of x is, in order to find x, you take the cosine inverse of those numbers,
Okay.
which will give you 1.29 and 2.2238.
And 2.2238.
Yeah. And then I don't know what they did after that to get like the 4.
I think they added 2 pi. Well, they added something to get, you know how it's like in the first quadrant and the fourth quadrant where it's positive. So maybe they added pi?
Oh, don't we need to add like 2 pi? Is it, remember when we did the
If
first
the
one?
numbers don't work out, that it would be like pi or 2 pi though.
Yeah.
Because like they added something to make it to where now it's in the fourth quadrant. Because that's where also cosine's positive.
Oh. Okay, maybe they took it like. I don't really.
Would it be or 3 pi over 2? Did they add 3 pi over 2?
I don't know where you're getting 3 pi over 2 from.
Because that would, it's in the first quadrant now. Our answers are in the first quadrant. If they added 3 pi over 2, wouldn't that put us down in the fourth quadrant?
I can look if these numbers work out fine. Pi times 3 equals 2. No. Oh, maybe they found 4 answers for x.
Oh, yeah, that could be a possibility.
Yeah, so for each one they found 2 answers depending on what quadrant it was in. You're right, because so they weren't adding anything, but they found like the cosine inverse of x, or the cosine inverse of whatever digit, whatever. It would be in 2 different quadrants. So they found 2 for each number, and that's where the 4 x's are coming from.
Yeah.
That makes sense.
Cool.
Cool. So then that's it, right? That's all we have to do?
Yeah.
Yeah. Awesome.
Yeah.
All right. We'll talk to you guys later.
So are we all good for Thursday at
7.
7?
Let me put it in my
I'm good at
calendar right now so I don't forget. Thursday at 7.
Look like I have a mustache out of light.
Okay, see you all then.
See you
Okay.
then.
See you guys.
Bye.
Bye.
Sorry, 1 second. All right, I think I just put it in. All right, see ya. Bye.
Okay.